NECA 406. 900 provides guidance on the installation of residential generators. Specifically, Section 4.12 addresses the situation where a generator set is permanently connected and has a main disconnect switch located inside the generator cabinet. The key question is whether this internal disconnect switch can serve as the required main disconnect between the generator and the transfer switch, or if a second, external disconnect switch is necessary. According to NECA 406. 900, Section 4.12, if the generator set already incorporates a main disconnect switch within its cabinet, that switch is considered suitable for use as the main disconnect between the generator and the transfer switch. This means that an additional, separate disconnect switch is not required in this specific scenario. To fully understand this, let's delve into the reasoning and implications. The purpose of a main disconnect is to provide a readily accessible means of isolating the generator from the electrical system. This is crucial for safety during maintenance, repairs, or in emergency situations. The disconnect allows personnel to de-energize the generator, preventing the risk of electrical shock or damage to equipment. When a generator has an internal disconnect switch that meets the necessary requirements, it effectively fulfills the safety function. The internal disconnect is typically designed and tested to meet specific standards for interrupting the generator's output current. It is also usually located in a readily accessible position within the generator cabinet, allowing for quick and easy operation. By allowing the internal disconnect to serve as the main disconnect, NECA 406. 900 simplifies the installation process and reduces costs. It eliminates the need to purchase and install a second disconnect switch, as long as the existing internal switch is adequate. However, it is important to ensure that the internal disconnect switch meets all applicable requirements. This includes factors such as the switch's ampacity rating, its ability to interrupt the generator's fault current, and its compliance with relevant safety standards. It is also crucial to verify that the disconnect switch is properly labeled and accessible. The labeling should clearly identify the switch as the generator's main disconnect, and the switch should be located in a position that is easy to reach and operate, even in low light conditions. In cases where the internal disconnect switch does not meet these requirements, a second, external disconnect switch will be necessary. This might occur if the internal switch is underrated, inaccessible, or not properly labeled. The external disconnect switch should be installed in a readily accessible location between the generator and the transfer switch. It should also be appropriately sized and rated for the generator's output current. When selecting a disconnect switch, it is essential to consider the generator's voltage, amperage, and horsepower rating. The switch must be capable of safely interrupting the generator's maximum output current under both normal and fault conditions. It is also important to choose a switch that is suitable for the environmental conditions in which it will be installed. For example, if the generator is located outdoors, the disconnect switch should be weatherproof and resistant to corrosion. In addition to the disconnect switch requirements, NECA 406. 900 also addresses other important aspects of residential generator installations. These include grounding, bonding, wiring methods, and overcurrent protection. It is crucial to carefully review and comply with all applicable requirements to ensure safe and reliable installation. Grounding is a critical safety measure that helps to prevent electrical shock. The generator, transfer switch, and all associated electrical equipment should be properly grounded in accordance with the National Electrical Code or NEC. Bonding is another important safety measure that ensures all metallic parts of the electrical system are electrically connected. This helps to equalize voltage potentials and reduce the risk of electrical shock. Wiring methods should be selected based on the specific application and environmental conditions. The wiring should be properly sized and protected against physical damage. Overcurrent protection is necessary to protect the generator and electrical system from overloads and short circuits. Fuses or circuit breakers should be installed in the generator's output circuit and in the transfer switch. These overcurrent protection devices should be sized according to the generator's ampacity rating and the applicable electrical codes. The transfer switch is a key component of a residential generator system. It allows the homeowner to switch between utility power and generator power. There are two main types of transfer switches: manual and automatic. A manual transfer switch requires the homeowner to manually switch between utility power and generator power. This type of switch is typically less expensive than an automatic transfer switch. An automatic transfer switch automatically switches between utility power and generator power. This type of switch is more convenient than a manual transfer switch, as it does not require the homeowner to manually operate the switch. When selecting a transfer switch, it is important to consider the size of the home's electrical service and the amount of power needed to run essential appliances during a power outage. The transfer switch should be sized to handle the maximum load that will be connected to the generator. It is also important to choose a transfer switch that is compatible with the generator. Some generators require a specific type of transfer switch. Before installing a residential generator, it is essential to obtain all necessary permits and approvals from the local authorities. The installation should be performed by a qualified electrician who is familiar with the applicable electrical codes and standards. A qualified electrician will ensure that the generator is properly installed, grounded, and wired. They will also verify that the transfer switch is correctly installed and that all safety requirements are met. After the generator is installed, it is important to regularly inspect and maintain it. This includes checking the oil level, coolant level, and battery condition. The generator should also be tested periodically to ensure that it is operating properly. Regular maintenance will help to extend the life of the generator and ensure that it is ready to provide power when needed. In summary, according to NECA 406/900, if a permanently connected generator set has a main disconnect switch inside its cabinet, this disconnect is typically suitable for use as the main disconnect between the generator and the transfer switch, negating the need for a second external disconnect, provided it meets all applicable requirements. Remember to always consult with a qualified electrician and adhere to all applicable codes and standards to ensure a safe and compliant installation. Always prioritize safety when working with electrical equipment. If you are not comfortable performing the installation yourself, it is best to hire a qualified electrician. Electricity can be dangerous, and it is important to take all necessary precautions to avoid electrical shock or other hazards. Here are some additional points to consider. Firstly, local codes and regulations may have specific requirements for generator installations that differ from NECA 406/900. It is important to check with your local authorities to determine the applicable requirements in your area. Secondly, the generator manufacturer's instructions should always be followed. The manufacturer's instructions may provide additional guidance on the installation and operation of the generator. Thirdly, the NECA provides comprehensive requirements for electrical installations, including generator installations. It is important to be familiar with the applicable requirements in the NECA. Fourthly, ensure that the generator is properly sized for the intended load. An undersized generator will not be able to provide enough power to run all of the desired appliances, while an oversized generator will be less efficient. Fifthly, consider the noise level of the generator. Some generators are louder than others. If noise is a concern, choose a generator with a low noise rating. Sixthly, protect the generator from the elements. If the generator is located outdoors, it should be protected from rain, snow, and sun. A generator enclosure can help to protect the generator from the elements and reduce noise levels. Seventhly, properly maintain the generator. Regular maintenance will help to extend the life of the generator and ensure that it is ready to provide power when needed. Eighthly, store fuel safely. Gasoline and other fuel should be stored in approved containers in a well-ventilated area away from heat and open flames. Ninthly, be aware of carbon monoxide hazards. Generators produce carbon monoxide, a colorless and odorless gas that can be deadly. Never operate a generator indoors or in a partially enclosed space. Tenthly, test the generator regularly. Testing the generator regularly will ensure that it is operating properly and that you are familiar with its operation. By following these guidelines, you can ensure a safe and reliable residential generator installation. Always remember to prioritize safety and consult with qualified professionals when necessary. It is imperative to understand the terminology used in the NEC and related standards. For instance, ampacity refers to the current carrying capacity of a conductor, while overcurrent protection refers to devices like circuit breakers and fuses that protect against excessive current flow. Furthermore, the concept of selective coordination is important in overcurrent protection. Selective coordination ensures that only the overcurrent device closest to the fault opens, minimizing the extent of the power outage. Another critical aspect is understanding the different types of grounding systems. The NEC specifies different grounding systems, such as the grounded system and the ungrounded system. The choice of grounding system depends on the specific application and the requirements of the electrical system. Additionally, understanding the different types of wiring methods is essential. The NEC specifies different wiring methods, such as rigid metal conduit, electrical metallic tubing, and non-metallic sheath cable. The choice of wiring method depends on the specific application and the environmental condition. Moreover, it is important to be familiar with the different types of electrical equipment, such as transformers, motors, and lighting fixtures. Each type of electrical equipment has specific requirements for installation and operation. Finally, it is crucial to stay up to date on the latest changes to the NEC and other relevant standards. The electrical codes are constantly evolving to reflect new technologies and safety concerns. Regularly reviewing the latest codes and standards will help ensure that your electrical installations are safe and compliant. Remember that electrical work can be dangerous, and it is important to take all necessary precautions to avoid electrical shock or other hazards. If you are not comfortable performing the work yourself, it is best to hire a qualified electrician. The information provided here is for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician or other professional before performing any electrical work.